Welcome to an algebra and surds video. This one is having a look at a whole bunch of factorization examples. This is video 1 of 2 here. Okay, to factorize, we look to find what's common between both terms. So here there's a 3 common, so that will go out the front. Then we ask, what are we going to multiply 3 by to get 3x? We'll need an x in that bracket. Then what have we got to multiply 3 by to get 9? Another 3. Now we can always check our answers when we factorize. If we expand that, 3 times x makes 3x, and there 3 times 3 is 9. We can check that we get back to our original question once we expand. That'll be a good double check. Here the thing that's common here is a 5, so we'll put a 5 out the front. And we'll need to multiply 5 by a if we want 5a. We ask, what are we going to multiply 5 by to get minus 20? That would be minus 4. Here we have a letter that's common. Y will be out the front. That's the common term to both there. We have to multiply y by y to make y squared, and y by 4 to make 4y. Here there's another common letter. N will be out the front. We'd need to multiply it by n to make n squared, and minus 8 to make minus 8n. Here we have a number and a letter that's common. The biggest number that's common there is 4. And there's an x that's common to both terms as well. So we'll take that out the front. We'll need to multiply 4x by 3 to make 12x. And we'd need to multiply 4x by minus x to make minus 4x squared. This one's got a number and 2 letters that is common. 2 can go into each. A can go into each, and B can go into each. What have we got to multiply 2ab by to get 6a squared b? We'll need a 3 to make a 6, and we need another a to make an a squared. And what have we got to multiply 2ab by to get minus 2ab? We need to multiply it by minus 1. Here, when we've got the 2 sets of brackets with the identical contents there, we're allowed to join up the y and the 5 into a bracket of its own when we factorize here. So we'll have y plus 5 in one bracket. Then we'll just list that y plus 6 once. Here once again we have common brackets here. X plus 7 is common. We're allowed to join the x and the minus 3 up in one bracket. And we'll list the x plus 7 in one instance as well. Now there's nothing common that goes all the way through all 4 terms, but there is something common in the first pair and in the second pair. So the method here is to factorize in pairs. That's the name of the method. What's common in those first 2? A is common. We'd need to multiply by a by b to get ab, and a by 1 if we wanted to get to a again. In the second term, and second 2 terms, we have, or actually the third and the fourth term if I'm precise, 5 is common, and we'd need to multiply 5 by b to get 5b. We'd need to multiply 5 by 1 to get 5 for our final term. Now those of you who were paying attention to the last 2 examples will notice that we have some common terms there in some brackets, allowing us to join the a and the 5, the front numbers, in their own bracket. So they can join up in their own bracket, and we'll just list the b plus 1 once. So 2 rules kicking in there. We're factorizing in pairs, and then we're joining up those front numbers into brackets, which can only really happen if those 2 brackets in that previous line are the same as each other. This one here looks very strange. We first check whether there's anything common between all 4 terms, and there is. M can go into all 4 terms there. So m can go outside of. We'd need to multiply m by mn to make m squared n for our first term. We'd need to multiply m by n cubed. We'd need to multiply m by minus 4 for that fourth term. Oops, just minus 4, not the m. Then we'd have to multiply m by minus 4m for that last term. That's not there, that one. Okay, now we could look to factorize in pairs here, but in this case it won't work all that well. It won't create one of those situations with common brackets to help us factorize further. So sometimes it's only one common thing that can be taken out of an expression. This is the first of our quadratic expressions. Use a method, a lot of students use a method called the PSF method. You can use what we call the cross method if you like, or whatever you like, but I'll remind you of how we use the cross method, the PSF method for this. We're looking for two terms, one to go in the first bracket with an x, and one to go into the second bracket. Now these two numbers, we have clues for finding those two numbers, and one clue is that the product of those two numbers is 6, and the sum of those two numbers is 5. So if the product of those two numbers is 6, a list of factors of 6 will be very helpful for us. We should be able to find those two numbers from a list of factors. And 2 and 3 looks a pretty good pairing here, because 2 plus 3 is 5 and 2 times 3 is 6. So that's what we're going to go with here for our factorized version. We'll have a bracket with x plus 2 in it and a bracket with x plus 3 in it. Once again, we can use the PSF method here. We're looking for the product of two numbers that to be minus 36, the sum of two numbers to be minus 5, factors of 36 that have got something to do with 5. 1 and 36 doesn't have much to do with 5. 2 and 18 doesn't either. 3 and 12 doesn't really. 4 and 9 looks pretty good. 4 and 9 will work. And we can play around with having a minus 4 and a plus 9, or vice versa. With experience you get to understand how these things might work. Now one of them needs to be a minus, because otherwise we won't get minus 36 for our product. And if we want to add two of these together, 4 and 9, and create a minus 5, I'm here to tell you that we'd need 4 to be positive and the 9 to have a negative, because when we add that together we'll end up with a minus 5 as our final result there. So you'll get more and more experience at that as you go. So these are worth practicing if you want to get better at them. So we'll have x plus 4. Oh, actually we're working in a's, aren't we? Sorry about the scribble. A plus 4, better get it right here. And a minus 9 will get us across the line. If we expanded that using FOIL or splitting that first term up, we should get back to that answer there. This one, our product of our two numbers needs to be 20. Our sum needs to be minus 9. Our factors of 20 that'll have something to do with 9 is 4 and 5. Sometimes it just comes to your head there. Both of them will need to be minuses. If we need to multiply them together to give a positive 20, and we can add minus 4 and minus 5 to get minus 9. So if you think that's a bit quick, just have a think about some of the factors of 20. It'll come to you when the right combination comes along. Sometimes you can swear blind that a pair of values are going to work here, but sometimes no combination of plus and minus will work. So you'll have to keep looking at the list of factors, and a different factor will work usually. So we'll need m this time, minus 4, and m minus 5 for our answer there. Alright, now this is quite a bit different. This front number here means we have to change methods a little bit, or add a couple of extra bits to our methods. Our product of the two numbers that we're looking for will be not just minus 15 like it normally is. We'll have to multiply those two together to get our product. So our product of the two numbers we're looking for the brackets is going to be 4 lots of minus 15, which is minus 60. Our sum is still going to be 17, and our factors of 60 are going to be 1 and 60, 2 and 30, 3 and 20 looks pretty good there, because we'll be able to make that into 17 quite nicely. Now what we're going to do here, we're going to call this 3x and 20x, because what I'm going to do is I'm going to split this middle term up, And I'm going to do this. I'm going to write down 4y squared, which was just that first term. I'm going to split the 17y up into a couple of different expressions using these down here so that we can factorize in pairs. I'm going to make it plus 20x minus 3x. Then I'm going to write that one last term down as well. So I've turned plus 17y, oh, that should be a y, sorry, and that should be a y. Apologies for that. But I've split that up so that we can then factorize in pairs. That's the other adjustment we need to make. So this is quite an adjustment. We adjusted the product number by multiplying the front number by the last term. Then we take our two perfect numbers that we find down there and express it in a 4-term arrangement here. So then we'll factorize in pairs here. What's the biggest thing that can go into each of them? We'll have 4y outside of y plus 5. And when we factorize this, the third and the fourth terms, we'll hope for a bracket that's going to be the same as y plus 5, so we can use that fancy rule of joining the front numbers up again. So if we say minus 3 that's common, we can have a y plus 5 for our bracket, can't we? We want to make those two brackets the same as each other if we can. Then we're allowed to join the 4y and the minus 3 up in the bracket of their own. Sorry if this is confusing, but it's worth practicing these factorizings with the front numbers not being 1. They're called non-monic quadratics. And we'll join and we'll just list the y plus 5 there. So if we expanded that out, we should get back to that rather challenging factorizing up there. So the two big adjustments we made were, instead of just having the product being that minus 15, we had to make that product the multiple of 4 times minus 5 and made minus 60. Then, once we got our two numbers down here, we kind of put letters next to them. They should be y's. Apologies. Then we split up that middle term so that allowed us to factorize in pairs and then kick in that rule where we can join the front numbers. So quite a bit different to the normal quadratic versions. This one, let's see another one here. The product is 6 times 20, or 120. The sum is 23. The factors of 120, let me just find my sheet of paper here, because I might be here for a while looking at the factors of 120. Bear with me here, I won't be long. Okay, the factors that we're looking for are 8 and 15. They add together to give 23 and multiply together to give 120, otherwise it might have taken us a while. Okay, so what I'm going to do is split up 23 into 8 and 15 here. So let's go with 6x squared plus, let's go 15 first, because it doesn't really matter what order we put these in. So I split, that's a 20 there, okay. So I split 23 up into 15 and 8, and then I'm going to factorize in pairs. So what's the biggest thing that can go out of this? I think we'd have 3x outside of 2x plus 5. And if I'm on track here, this next bracket should work out to be very similar. Plus, I think we need 4 outside of 2x plus 5. That'll work nicely. And then we're allowed to join the 3x and the 4, the front numbers, up into one bracket. And then just list the common bracket there, the repeated bracket, 2x plus 5 once. Alright, so that's a big one. We might have been there for a while with the list of factors of 120 that have got something to do with 23. But anyway, sometimes there's a challenge. Alright, factorizing this one will be a bit interesting. We're back to normal quadratics here. If we do PSF on this, we'll be finding two numbers that multiply together to give 9 and add together to give 6, and I'm here to tell you 3 and 3 will work. Now because we've got 3 and 3, we'll end up with a plus 3 in one bracket and a plus 3 in the other bracket. So we could write that, because these are the same brackets multiplying with each other, we could write it in this form: a plus 3 all squared. Now I'll show you a little bit of a shortcut here. This is called a perfect square, this, when it's allowed to be factorized into one bracket just being squared. The way to spot a perfect square is if you divide that middle term by 2, I'll get 3, won't I? And if I can square that to make the final number, 3 squared is 9. So if you halve that and square it and to get the third term, then it's that half version, or the 3, that'll end up in the bracket that's getting squared. So sometimes you can spot that shortcut. Try and get used to those. Okay, this one here, if we PSF'd this one to factorize it, we'd have to multiply 4 by 9, which is 36 for the two numbers. The sum is 12. Factors of 36, 1 and 36 might not be all that great, but 2 and 18 might not work. 3 and 12, 4 and 9, 6 and 6 might work quite nicely because 6 plus 6 is 12, 6 times 6 is 36. So what we will have is we need to split this up, so we'll have 9m squared plus 6m plus another 6m plus 4. So we'll split the 12m up into 2, and let's factorize in pairs. The biggest thing that can go into these first pair is 3m, which we'll need to multiply by 3m plus 2. Biggest thing that can go into there is 2, and that will be 3m plus 2, creating an identical bracket there and there. And we've seen this rule a number of times. We can join the front terms up in their own bracket and list that common bracket once, but those of you who are watching carefully here will notice that they're the same as each other. You get 3m plus 2. We could express it as that all squared. Now, in an interesting way, when these things work well and it ends up being a perfect square, what happens is you can square root this first term. Square root of 9m squared is 3m all squared, and the square root of this term here is 2. That gives you a bit of a clue as to what should be in our final bracket. So there are ways to not necessarily go through this whole PSF method if you can spot one of these perfect square patterns. So listen when you're doing that in class. Okay, so let me just use this shortcut version here. I'm here to tell you this works out to be a perfect square. So if I square root this first term, I get 2y being all squared, and 25 could be turned into 5 squared. So let's see if, and we'll need a minus in our answer. So a shortcut way of saying this is 2y minus 5 all squared. Now, the way to double check this is if you can multiply by 2 by the two items that you propose to go into the brackets. Into the brackets we were going to put a 2y and a minus 5. If you can double those two, you should get to this term here. So 2 times 2y is 4y, times minus 5 is minus 20y. That's just a double check to see if this is actually a perfect square. So when it is a perfect square, you can square root that first term, write it down in the bracket, square root that last term, write it down in the bracket. You need to double check that it's the right arrangement for that middle term as well. So that's a real shortcut one, that one. Don't worry too much about that. Alright, there's the first bunch of examples on that topic, so we'll see another bunch in the next video. Thanks for watching. See you next time. peterblakemaths.com